Hi, I'm Bill and this is Math Fundamentals. Last time we talked about quadratics, we talked about area of squares and rectangles. Today we're going to talk about kind of the opposite idea. We're going to talk about factoring. Most of the time it's not presented in relation to squares and rectangles. I'm going to show you how you can think of it the same way. I'm also going to show you how it's normally done. It's a very useful tool. It's used often in math. We're going to expand upon it. Today we're just talking about factoring integers. Anyway, let's begin. Okay, so when you're factoring a number, it's really just taking a number and finding out what you would have to multiply to get that number. It's like, what are the parts that make up that number? So like you can get 12 by multiplying 1 times 12. You can get 12 by multiplying 2 times 6. You can get 12 by multiplying 3 times 4. These are all factors of 12. A lot of times people write a t-table to do this. So you make a t with the 12 on top, and then you list the factors here. 1, 12, 2, 6, 3, 4. All these numbers are factors of 12. Now you don't have to be limited to just 2 things to multiply, like 2 factors. You can break it down more. It's like, for example, instead of doing 1 times 12, you could say that this is 1 times 3 times 4. Those 3 numbers together would be factors of 12. Or you can write that and break it down more as 1 times 3 times 2 times 2. If you multiply those all together, you'd get 12. This is breaking it all the way down. You can't break it down anymore. Here I broke down 12 into 3 and 4. Here I broke down 4 into 2 times 2. This is called prime factorization. Prime factorization is when you break it down into as many factors as you can until you can't break it down anymore. People make a factor tree a lot of times for this. Like 24, what you would do is you would make like 2 branches, and on each of these you would put 2 factors of 24. It doesn't actually matter which 2 you choose. It's all the same. You could say 2 and 12. 2 you can't break down anymore. Like, sure, you can make 2 branches and say 1 and 2, but you can't break down 2 into anything else. But 12, we could break down into 3 and 4. 3 we can't break down anymore. The only 2 factors we have of 3 are 1 and 3. 4 we can break down into 2 and 2. So if you take all of these factors at the bottom, these are like your prime factors of 24. So you have 1, you have another 1, it doesn't really matter, you don't have to write it again. You have 3 2's, and you have a 3. These are the prime factors of 24. Most of the time you don't have to write the 1, but if you have 2 times 2 times 2, repeated multiplication, you use an exponent. So 2 cubed is the same as 2 times 2 times 2, and then times 3. This is prime factorization of 24. Now, I keep throwing around this term of prime. If you don't know what prime means, it's a number that can only be broken up into 2 factors. And the only 2 factors are 1 in itself. 7 is prime because the only 2 numbers that you can multiply to be 7 are 1 and 7. 1 in itself. If you had a number like 4, 4 is called a composite number. Because sure, you have 1 and 4, but you also have 2 and 2. So that's a composite number. This is prime. 2 is the only even prime number, because any other even number you can write as 2 times something, like 6, 2 times 3, 12, 2 times 6. Any even number, you're going to get 2 as one of the numbers. Another interesting side note, what about 1? Is 1 prime? Factors are going to be 1 and 1. There are times throughout the centuries where 1 was considered prime, and times where it's not. Right now, it's not considered a prime number. Maybe we'll talk about that in another episode, but it's something to keep in mind. 1 is not prime. So you might be saying, Bill, I thought we were talking about quadratics. Quadratics being a 4-figured side like a rectangle or square. Why are we just talking about numbers right now? And the reason is because I'm going to relate factoring to rectangles, because as we go further working with quadratics, we're going to need to know how to factor them. So we need to understand what factoring is. So let's say we have a rectangle. We're looking at factors of 36. So to relate it to a rectangle, this 36 that you're trying to find factors to is like the area of a rectangle. And then when you find the factors, you're really just looking for what are the 2 side lengths. That would give me 36. So you could have a rectangle that's 1 and 36, just like in a factor tree. So 1 and 36 could be side lengths of that rectangle. You could have side lengths of 2 and 18. That would also give you a rectangle with an area of 36. You could have side lengths of 3 and 12. That would give you a rectangle with an area of 36. You could have a rectangle with sides of 4 and 9. That would give you an area of 36. Or you could have side lengths of 6 and 6. That would also give you an area of 36. Just because we're looking at factors of a number, it doesn't mean that we can't relate it to other parts of math. A length and width of a rectangle, it's just two numbers being multiplied together, so why can't we call them factors? And again, you're probably saying, Bill, come on. I'm not going to sit there and draw all the different types of rectangles when I could just make a t-table or a factor tree and find it that way. Why would I bother doing this? You won't. But where you will be using it is when we're dealing with variables. So if you had x squared and we're looking at the factors of that, remember what I said in the area video whenever you have a square term? Think of a square. X squared is a square, is an area of x squared, and it has side lengths of x and x. So your factors of x squared are going to be 1 and x squared, yes, but what we're going to use more of is x and x. That's what you need to know. The other thing is if we're looking at factors of x is just any number. Think of a rectangle. No matter the number, if you're finding factors of 2, you'd get 1 and 2. If you're looking at 4, you'd get 1 and 4 and 2 and 2. If you're looking at 8, you'd get 1 and 8, 2 and 4. If you're looking at 13, you get 1 and 13. The pattern with all of these is you always have 1 in itself. So if x is any number, you can always have 1 in itself would be factors of x. This fact that x can be thought of as a rectangle with side lengths of 1 and x squared can be thought of as a square with side lengths of x and x, we are going to use extensively in solving quadratic expressions and equations. So that's factoring a regular integer. It gets more complex when we're talking about variables and quadratic expressions and equations, which we'll be looking at next time. If you have any questions or comments, leave them in the comment section below. If you like this video, please like and subscribe. And as always, keep asking questions. Head on over to the Facebook page. There's a link in the description below where we can have additional conversations about this topic. Thanks for watching. I'll see you next time.